Hi, Cecil.
Thank you so much, Seth and Donna. Hi, everyone. Thank you so much for joining me today for my session. Hope you all have been having a great time at Start Dev Change. My name is Cecil Phillip, and I'm a developer advocate at Microsoft. And what we're going to do in the next few minutes is talk about some computer science fundamentals. And we're going to kind of use the Python programming language to kind of help reinforce some of those things. So why don't we get started really quickly? And let's talk really quickly about what exactly we're going to cover in the next few minutes, right? I definitely want to talk about, what is computer science, right? Because I think it's important for us to understand like what it is and what's the role that it kind of plays in our life and in our world. We're going to talk about what are computers good at. We're going to talk about, what are algorithms? Because I think those are some things that are very fundamental for really understanding like the whole concept of computer science. And then, hopefully along the way, we'll learn a little bit of Python too. No, I can tell you some things that we're not going to be able to do. Like, I'm not going to be able to teach you computer science in 25 minutes. I'm also not going to be able to teach you Python in 25 minutes. But hopefully, after watching this, you get a little bit of inspiration for you to go ahead and continue learning and trying some things out. So let's go ahead and get started. What exactly is the purpose of computer science, and more so importantly, like what do we really think is the purpose of computing in general? And I know some of you might have had some classes, or maybe you're thinking about going and starting some classes. And so you might have your own definitions of what that is. But I want to give you Cecil's definition of what computing is really about. And for me, it really comes down to a very fundamental concept, right? We want to be able to move information from one place to the other. We want to be able to store data, or we want to be able to retrieve data, right? And really, that's what we're talking about. If you think about like the devices that are in your pocket, if you think about some of the things that you do day to day with like your phones and our laptops and computers, it's really about sharing information, right? If I have an idea in my head, like how can I type it into like a Word document, and how can I share that Word document with you? If I'm doing some type of research and maybe some of my colleagues are different parts of the world, like how can I really share that information with all of these different types of people? And how can these devices, and how could this really interesting piece of technology help me do that? Right. And that's some of the things that for me is really at the core of really understanding the purpose of computer science. Now, within the industry, like there's tons of little bits and pieces and like different categories that we could kind of put this into. We think about like machine learning, or we think about tech. We think about security, or we think about databases, or we think about networking, right? All of them with their own respective like areas of focus and things that they're really concerned about. But in each of them, the core is, well, how do I protect that information? How do I share that information? Right? How do I get it from one person to another person? Right? And this is where we really rely on computers to help us do that. With computer science being the study of how we can efficiently use computers to help us achieve our goals. Now, I'm going to give you a secret, right? Computers are actually really dumb devices, right? And what do I mean by that? Like computers by themselves really don't do a lot of things, right? Computers are only useful when people are involved. And that's what I mean by that. Computers need people to function. They need people to tell them what to do. They need people to help them operate, right? They're good at a lot of different things. They're really powerful and they're really intelligent. But I think we need to always remember that computers are for people, that software is for people. Technology is really for the advancement and betterment of society, to help us share information better and to help us communicate and connect with each other in a better way. Now, I said computers are dumb. Don't get mad at me. But, there are a lot of good things that they're good at. Like, for instance, like they're really good at calculating and doing work really quickly, right? They're also really good at storing and retrieving information. They could do that much faster than us as human beings do. And they're also really good at communicating with each other. If we think about like the internet and what it is, right, and how easily that we can get information from, to and from our family members all across the world. How again researchers can store and share information with their colleagues that exist, regardless of whatever their geographic locations, right? Like they're able to do these things very efficiently and much better than we can, right? And so, with the combination of people, right? And this is gonna be a theme that I'm gonna talk about a lot, is the importance of people in computer science and in technology. With the addition of people and computers as, kind of like an extension to our brains and our thought patterns, we're able to really achieve some really amazing things. And now when we think about computing now we think about, well, how exactly do I talk to these things, right? And we talk to them using programming, right? Programming languages are, there's tons of different languages that folks can learn and they could try out and we could use. But, this is what we actually use to communicate with these machines, right? This is what we use to tell them, well, this is how I want you to do whatever this particular task is, right? And again, like I said before, there's tons of different languages with different benefits and different purposes and different contexts where they really excel at doing what they're doing. So with that being said, what I actually want to do is I want to dive over and I want to take a look at Visual Studio Code, and I want to show you how we could start programming, using a language called Python. Now, Python is a great language for you to learn, regardless of whether you're new in terms of getting into computer science and new into programming, or whether you're someone that's already been in the space for a really long time. The great thing about Python is that it doesn't take a lot to get started. And there's tons of support for doing things like, again, I could do machine learning and I can build web apps and I do tons of amazing things. Or if I really just want to do something really quick and simple, it can help me as well. So it's a language that kind of stretches out and it spans and, it supports a lot of different type of learning styles. And it also supports a lot of different types of scenarios in terms of folks really trying to understand, well, how can I achieve this thing? Or how can I do this thing? So what I'm going to do is I'm going to hop over to Visual Studio Code really quickly. And why don't we start writing a little bit of Python code, and we could start to see some of these computer science concepts and how we can apply them to this language. So the first thing I want to talk about is variables, right? And I'm going to start typing here really quickly. So I'm inside of Visual Studio Code right now, and let's start talking about variables and what variables are. Now, if you think about a package, right, or an envelope, or maybe you're ordering stuff online. I know this is a time a lot of folks are ordering stuff. Everything we put things inside of like a box. And I can think about programming and I think about variables as like a box. Like I'm going to put something inside of this box, right? What might that thing be? So that might be something like, I don't know, let's just call it stuff, right? I'm going to put stuff inside of a box. Now, what I've just done is I've created a variable in Python called box, and I've just literally put some stuff in it, right? And that's how easy it is for you to get started, like writing Python and adding, creating a variable that has stuff. Now, if I want to peek and see what's inside of that box, if I want to see like what kind of stuff is actually in there, I can just simply print it out. So already we've seen how I can create a variable and I could put some stuff in it. And then now I can get some stuff out of it. And what I'll do is I'm going to hit this run button really quickly. And we'll see at the bottom here, notice it says stuff, right? Which is what I'm expecting it to do. Like I wanted to print out the stuff that's in the box. Okay, so you've seen how to create a variable, but what exactly is a variable, right? Our variable essentially is just a container for us to put things inside of. And we think about it like, hey, I might have numbers or sentences, or I might have some information that I got from a database, or maybe even my document that I wanted to store somewhere, right? Like I can put it in something called a variable, right? And its job is to hold that information, right? Here I have a box. I'm going to put stuff inside the box, and now I'm going to be able to do different types of things with it, right? If you think about, for instance, if I want to create another variable, let's say I got to call this like number 1, right? And I'm going to put 1 in here, and I'm going to have number 2, and I'll put 2 in here as well, right? Now we can have these 2 variables, and I could start doing work with them, right? So when we start doing work with variables, we start to talk about things like operators. Like how can I carry out operations on these different numbers? So again, I could do something like num1 plus num2, right? And now this could be like the answer, ANSWER, right? But again, I've just created another container, all right? And the job of this container is to hold the results of this operation that I carried out, right? So I did some stuff with the first 2 numbers, and now I'm going to go ahead and I'm going to store it somewhere, right? I'm going to put it in the variable. So that's what we think about variables as, places where we can go ahead and we could store stuff in. Now, in addition to just being able to store one variable, I'm going to get rid of this here really quickly. I might want to store more than one thing, right? So again, imagine that we're placing an order, right? And I want to have a list of different things, right? Want to have more than one thing that I'm ordering. Like I might want to order, let's say I need flour, right? I need to go to the store and I need to get some flour. I need to get some eggs. Maybe I need to get some milk, right? Here's my list, right? Here's my list of things that I need to order, right? And now, again, instead of just worrying about, hey, I just have one variable with one value, now I have this order that has more than one value in it. And as you go on and you start reading about computer science and learning about it, you're going to hear the word data structures come along. And data structures being, what are these different constructs within programming that we could use to represent information in a different way? So for instance, like what I've created here on line 4 is a list. So inside of my list, I have 3 different things inside of it, right? I have flour, I have eggs, and I have milk, right? So those are the things that I need to get from my list. Now, what if I had another list, right? Let's think about this really quickly. Let's imagine that I'm home, and imagine if I'm home and I want to make a pie, right? Or I might want to make a cake or something like that. Like, how would I do that? Well, if I want to make a cake or a pie, then I'd need ingredients, right? So for my ingredients, I might have something like, let's say I want to make an apple pie. I'll have apples, right? I'll have sugar. What else I might need? Apples, sugar, whatever it is. We can have tons of different things that we can add to our ingredients, right? So now I have a variable for ingredients and I have a variable for order. Now, what I want to do is I want to place my order. And now I want to say, okay, now that I've ordered this stuff, well, I want to add, my order, the stuff that I've ordered to my ingredients. And hopefully this makes sense to you, right? So I have ingredients, and now I've went ahead and ordered some stuff. So now I have ingredients plus the stuff that I've ordered, right? And so this is what we talk about, again, like doing operations. What I've done is that I've taken some information that I've had, and I've gone ahead and I've added it to the other stuff, right? So now if I look inside of my ingredients should be more than just what I had before, which was just these 2 items, right? Now my list has gotten bigger because I've went ahead and I've added stuff to the list, right? Now I have flours, I have eggs, and I have milk inside of it, right? And so if I go ahead and I print this out, I'm going to go ahead and run this. You should see at the bottom, hopefully you could see this, right? It says now inside of my ingredients, I have apples, I have sugar, I have flour, I have eggs, and I have milk, right? And so really quickly, we've seen how we can create variables using things like, one just this one just holds a string of stuff, right? It just holds the name of something. And then this one actually holds a list of different things, right? So again, we've been able to add additional stuff to our list. So those are variables, right? Like variables are things that we could use to store stuff. Let's talk a little bit about functions, right? And why functions are important. Okay. I'll type functions really quickly. Functions. I'm sorry for the all caps. Now, functions are great when we actually want to let the computer know, hey, I want to go ahead and carry out a task, right? I want you to go ahead and do something for me, right? And of course, I can very easily like just type it out here if I wanted to, but maybe I want to be able to run a particular task or operation more than one time. And in that case, it might be good for me to create a function around it, right? So let's go ahead and create a function called recipe. So in Python, we create functions like this, right? I'll use the def keyword, and then I'll say recipe, right? I'll put a colon there at the end. And then now inside of, inside of the indented area, right? Notice I had to come over a little bit. Now inside of here, I'm going to say, well, what are the steps that I actually want to do inside of this recipe, right? Like, how do I actually bake this pie, right? Like, how do I make this thing that I wanted to bake? Well, the first thing that we got to do is that we got to give the recipe the ingredients, right? Right now, our recipe knows nothing about our ingredients. So we have to give it ingredients. So what I'll do here is I'll type ingredients in here, okay? That means that whenever I'm going to run this function, whenever I call this function, the function needs to have some information about those different ingredients that we ordered earlier. And now inside of my recipe, now I could start putting my cake together, right? So let's say I want to make like a pie. right? So if I want to make a pie, well, that means that, well, I need another variable, right? I need a variable to actually hold my result. And my result should be that pie. That's that thing that I want to make, right? And now inside of my pie, what I want to do is go over every item in that list one at a time. So first I want to look at the apples and sugar and eggs and so on and so forth. And I want to put them together, right? I want to put them together to make my pie. So how would we do that? So it turns out there's these thing called loops, right? And looping is a way that we could, again, iterate over different lists of things, or look one at a time over a collection of things and say, well, hey, let me look at this item and let me look at that item and let me look at the next item and get that information out of there. So for instance, let's say I wanted to get all that stuff out of my ingredients. I could say for item in ingredients, right? And so this is how I'm going to go ahead and look through those different items that are inside of here. Items in ingredients, I want you to say pi is equal to pi plus item, right? And that makes sense, right? Because that's how we make a pie, right? Like we add all of these things together, right? And so I'm going to go ahead and I'm going to run this now. And what I'm expecting, well, whenever I run this operation, what it's going to do is going to say, okay, inside of my ingredients, inside of my recipe, I have all these items. I'm going to add them together and I'm going to make a pie. Right? Now, if I go ahead and print this, now this will be at the end of the function. I'm going to go ahead and print this. And if I print the pie, what I'm expecting to happen is, well, I'm expecting for this thing to, well, let me know what's inside of my pie, right? So that makes sense. Now, I'm going to go ahead and run this. But notice when I run this, well, nothing happened. Well, where's my pie, right? Like we just got all these ingredients and we wrote this function. There's no pie here. Well, it turns out we actually have to run the function. We have to tell the computer to run it. Again, remember, like I told you before, like computers are dumb. They only do what we tell them to do. So even though we created these variables and we created this function, we actually haven't told it to run it yet. So we need to do that first. What I'll do is I'll go ahead and I'll call recipe, right? That makes sense, right? And I'll run this. Oh, and it looks like I got an error. It says missing an argument ingredients. Well, okay, well, that makes sense again. Remember, computers are dumb. We have to tell them what to do. So even though I called recipe, it doesn't know what ingredients exactly I'm giving it, right? I actually have to take what we defined here on line 8, and I have to pass it into the function, right? I have to provide information to the function so it'll know how exactly to do what we did, what we need. So then I'm going to go ahead and type in ingredients here. Oops, not that one, right? I'm going to type in ingredients. And now if I run this, what I'm expecting to happen is, oh, we got like a really weird word there. I don't know, apple, sugar, flour, milk, X, something, right? Like it's all garbled together. Well, that doesn't look like a pie, you know? But again, computers are dumb, right? Like we didn't actually tell it how to make a pie. We just told it, well, hey, you have all these ingredients. Like, go ahead and pop that stuff together. And well, all it did was it took those variables and it really just it just mushed them together in another variable. So probably what we want to do is something a little bit different, something a little bit more intuitive, right? So let's make a change really quickly inside of our code, right? So I'm going to go back inside of my Python function, and instead of just adding all my ingredients together, instead I'm going to do this. I'm going to print out some instructions. And what I'll do, I'll print it out and I'll say something like add item to mix, right? So again, I'm going to add all of my items to the mix. And all my items, again, being eggs and things of that nature. And then after I'm done looping, right? Remember, my loop is going to go through each of these things one at a time. After I'm done looping through all these things inside of the list, now I could print another statement. I'm going to say something like put mix into the oven. Right? I think that makes sense. Right? So let's go ahead and run this. And now this makes a little bit more sense, right? Like we think about what it takes for us to make a pie, right? I want to add apples to my mix. I want to add sugar, flour, eggs. I want to add milk. And then I want to put my mix into the oven. And then I want to bake it, right? Now, what we've done here, in addition to one, we saw how we could create a function, and two, we saw how we could, create loops. What we actually did was we created an algorithm, right? And an algorithm is very important, regardless of whether you're doing Python or .NET or Java or JavaScript or whatever programming language you're using. It's important to understand algorithms. And algorithms are the instructions or the methods that we use to let the computer know, well, hey, this is how I want you to do this thing, right? So if you think about it, well, they might be different ways of like looking through a phone book. They might be different ways of doing gardening. They might be different ways of, turning on and off the light bulb in your house. You know what I mean? And when we talk about algorithms, and particularly when we talk about algorithms in computer science, it's about finding what are some of the best, most efficient ways for us to really make the computer do what we want to do as efficiently as possible. And so again, we used our yeah, we created use an algorithm to go ahead and create this. Now I'm going to head back to my slides really quickly. Now, it's more important for us to think about not just how we can get the computer to do stuff, but it's also important for us to think about how it does it, right? If you remember what I said earlier, like computers are for people, right? And without people, then, the computers aren't really that useful. But then we can also think about, well, people kind of need people too, right? So, without other people, like what is software really for? And what is really the point of us like making and building all of these things? I can give you an example. Imagine that you're building a house and it's like an amazing house and it has all these bathrooms and bedrooms and it has tons of great stuff in it. And you invite your friends over and your friend comes to your house and your friend is unable to come through the door of your house. And I mean, they feel really bad. Now they want to spend time with you. Now they want to come inside. But the thing is, you built this house, but you didn't think about some other people. You only really thought about yourself at that moment. When we start thinking about other people, the importance of thinking about these algorithms is us really understanding, well, how could we, how does this best serve everybody? How can I make a door that my friends could come into regardless of the shape of their body or how tall they are or how short they are? You know what I mean? We think about a lot of machine algorithms that may favor people that, look or speak or behave a certain type of way. Well, we need to really take the time and think about, well, how can this support and benefit everyone? And so this is where I have the term empathetic algorithms, right? And these are some of the things that as you become a computer scientist and as you start digging into the world, like these are some of the things that you could really need to think about. One of the things that a lot of folks always ask is, how can I become a better tech person? Like, how can I become better? And, just like I spoke about before with the empathetic algorithms, we really need to care about what we're doing. You need to have the passion for whatever you're doing. Because when you have a passion for something, when you care about something, that's when you're really going to put the time and effort into doing it, right? So for instance, I try to use an example where, hey, I know a lot of folks are ordering stuff. How can I make ordering more efficient? I know a lot of folks are home and you might be baking and cooking stuff. How can I share recipes with everyone more efficiently? How can I take what I've learned in my life and have computer science apply to that and help it make me and my life and my family's life a lot better, right? And these are some of the things that folks really need to think about as they go on. So I do have some homework for y'all. I know that was super quick and we kind of rushed through it, but here's what I want you to do. I want you, as you're going through your journey and you're understanding this world of technology and computer science, really think about how does computer science affect the lives of everyone that's around me? How can I use technology to make our lives better? And what are the things that I really care about and I'm really passionate about to really help push this thing completely forward? Now, thank you all so much. I really appreciate y'all joining me. I got to go now because I know there's some other great speakers that are here to talk to you all. But Seth and Don, I'll kick it back to you, and I hope everyone has a great time and enjoy the rest of the conference.
Well, that was fantastic. I had a good time learning Python with Cecil. Someone in the Twitchers, is that how you say it?
No.
Someone in the Twitchers said we should clone Cecil so he can teach every computer science 101 class in the universe.
I like that.
Yeah, I feel like we can do that.
Yeah, can Python do that? Cecil, can Python do that?
Can Python clone him?
Yeah, can Python clone you? I don't know. anything about Python other than white spaces matter? Forget this language.
No, it actually is kind of cool. I mean, there was also some comments about, there's other languages to do scientific stuff. Absolutely. My particular suggestion to everyone is use what makes you happy.
Yeah.
And solves the problem, right? But in that order. Use what makes you happy and solves a problem. You know what I'm saying?
Yeah. No, I know what you're saying. I also like Cecil's homework a lot, which is think about the world around you, identify a problem that you're facing either in your life, your home, your work, and figure out how to build a tech solution to solve that problem. Learn the language you need to learn to solve the problem. So if it's a website, don't learn C++, like I tried to. So don't do that.
You try to do C++ on a website?
Of course I did. I'm like, C++ solves everything. It doesn't.
Earlier I said I don't like cleaning up after myself. It's because, and the reason why it's a funny joke, and I was like, oh, maybe I should explain that joke. It turns out that programs basically are not super smart. They basically allocate memory in, and then those little boxes that Cecil was stuffing stuff into basically stores it. In certain languages, like once you store a variable there, it will automatically take care of removing the memory, so it's free. You don't run out of memory. Programs like programming languages like C++, you have to allocate the memory and deallocate it.
Yep.
So basically, it's like you have to clean up after yourself. And so when I'm saying, hey, Donna, I would like C++, but I don't like cleaning up after myself, that's the joke. Is it still funny if I explain it?
It was not funny the first time also.
No, I think it's funnier now that I explained it. I mean, let me see.
Are silent.
Let's see what the Twitch
the
folks say.
They're like, no.
Yeah,
No.
I got an LMAO. I think that's laughing my
You can't say it out loud.
tuchus off.
Wow.
LMTO is what I'm going for. Thanks for that, Seth. Someone was excited that I explained it to me. That I explained it to them.
Your programming joke. Okay, so let's take to the Twitterverse because we've been getting some tweets from you.
All right, so let's go over to the tweets here.
See what we got. Start Dev Change. Azure. Hi, Azure. So by the way, Azure, that is her real name.
What?
Yes.
Does
Azure
she work
McFarlane.
with us?
No, she doesn't.
What?
But she is an amazing Power Automate expert. Hi, Azure. And she got voluntold into this, of course. And she's going to be doing a killer session on Power Automate, which is business process writing with like low code tomorrow. So tune in to see Azure session. She is very funny, and you will really, really like.
We will literally be selling Azure tomorrow.
A little bit, but she said you should be nice to computers because
That's true. She said,
movies.
my mom says please and thank you when asking Google questions to be on their good side.
Yep. So what else we got?
All right, so let me scroll down here.
So Logash is diving into the Twitch. Hi, Logash.
Look at this one.
Thank you.
Tuning into Start Dev Change, listening to Cecil Phillip talk Python. I'll be hanging out in the Twitch chat, so come say hi. Let's just do that right now.
Okay.
Hi, Kim.
Hi, Kim.
Hi, Kim.
Hi, Kim.
Boom.
It's
Hello.
us.
Very
us.
nice. Oh, Twitchception. Can't do that.
Don't do Twitchception again.
Here's another one from Mari. Turned into Cecil Phillips' talk on computer science. I love how he's breaking down computer science concepts into simple terms. Computer science doesn't have to be scary.
No. How many of you, and here's a question that we would love to hear an answer from on Twitch or Twitter. How many of you have ever taken a programming or computer science class or boot camp or any sort of thing and walked away feeling stupid because it just was not taught very well?
Basically, all of grad school for me was me feeling stupid for 4 years.
That's fair.
Yeah, and I remember sitting in class, I'm like, are they trying? If you, no joke, if you read like an academic paper, there's actual strategies on how to read them to understand them. And I'm like, shouldn't
You just read them?
the author of the paper like use strategies to help us understand them?
Yeah.
And if you ever run into like, and I'm guilty of this too. So if you ever run into someone that's usually using overtly like flowery terms that seem a little esoteric, sometimes it's just that we feel like maybe we need to overcompensate for not knowing. Look, I lived in Spain for 2 years, and this dude I sat with him, smartest guy I ever met. He's like, Seth, it turns out that knowledge is like a piece of paper. The more you know, the more edges there are of learning. And so the smarter you get, the dumber you realize you are.
I agree with this.
Yeah.
Because you realize how much you don't know.
Yeah.
Like when you're young, you think you're very smart because you don't know what you don't know, which is a lot. There's so much to know.
I know.
But anyway, we'd love to hear the answer to this question because I failed my first computer science class. I roll up into first year of college, CS class, never coded in my life. And the professor's like, okay, we're going to learn bits and gates and binary language first, assembly language second, C++ third.
Whoa.
Let's start. So we started with binary, University of Michigan, Go Blue, very serious about their programming languages. So my first language was binary for a semester.
What?
You can imagine how badly I failed that, so badly. But 60% of people failed it, and it's called a weeder because it weeds people out of the degree if you don't want to be there. But I didn't think that was a very kind way to welcome people to computer science.
Why are you going to weed people out?
Now we're like, weed people in, join the industry.